All right, our third lesson for radicals is we're going to talk about multiplying radicals today. So we've talked about how to simplify radicals and how to add and subtract. So our next operation is multiplying, and I think you're going to notice that you've kind of been doing this all along. So let's start with our warm-up here. So your warm-up says to find the perimeter of this equilateral triangle. So you notice that all three of those side lengths are the same. The side length is the square root of 48, and you need to find the perimeter. Go ahead and pause your video and do that. So if you remember, perimeter means to add up all the sides. So you could say the square root of 48 plus the square root of 48 plus the square root of 48, right? Or you could also write that as 3 times the square root of 48, right? 3 radical 48 would be another way. You can see that all three of those radicals are like radicals, so you can add the three of them together and you get 3 radical 48. But we're not done yet because we need to make sure that we reduce or simplify that radical. So the square root of 48 would be the square root of 16 times the square root of 3. So square root of 16 is our perfect square. That's going to come to the outside. The 3 is going to stay in, but I can't forget to bring down my 3 that was already on the outside. The square root of 16 is going to become 4. Remember that all of these are factors. They're multiplied together, so I'm going to multiply those two numbers together on the outside. And left on the inside is the square root of 3. So then I have 3 times 4, which is 12 radical 3 for my perimeter. Now, if you'll notice there, you did actually multiply radicals. 3 times radical 48 gives you 3 radical 48. Outside times outside, inside times inside, right? Kept it the same. And then when you were doing this, you were simplifying, you were also multiplying, right? When you pulled something to the outside, you multiplied it together and you left it on the outside. That's exactly how we multiply with radicals. So here's our first one. If I said I wanted 6 radical 5 times 4, well, you'd multiply the 6 times the 4, right? Outside times outside. And the 6 times 4 will give me 24, and that's going to stay on the outside, right? There was nothing else for the radical 5 to multiply by, so it just stays as radical 5. That's it. But outside times outside stays outside. Now, if I look over at number 2, here I have 2 radical 7 times 3 radical 2. So if I'm going to multiply these together, I'm going to multiply the 3 times the 2 out here. So again, outside times outside. My answer is 6, and that's going to stay outside. But now I have radical 7 times radical 2. So when I do this, then I'm going to do inside times inside. So 7 times 2 gives me 14, and that's going to stay inside. 6 radical 14. So outside times outside stays outside. Inside times inside stays inside. Always try to reduce afterwards. Square root of 14 is 7 times 2, though neither one of those factors are perfect squares. So that's all that we can do. But that's the basics, and you've kind of been doing a lot of it already. So it's just kind of putting a name to it now. Outside times outside, inside times inside. All right, let's take a look at this next one. Now we've got 12 radical 10 times 4 radical 2. Outside times outside gives me 48 on the outside. Inside times inside, radical 10 times radical 2 gives me radical 20. Now I'm not done. I got to make sure that I reduce my radical. So I have the square root of 4 times the square root of 5 as my factors of 20. Square root of 4 is a perfect square. Make sure I bring that 48 down on the outside that was already there. I'm going to multiply it times, let's see, square root of 4 gives me 2. But the radical 5 is going to stay inside. But here now I have two things on the outside. 48 times 2 gives me 96 radical 5. All right, so just kind of one extra step. Other than that, it's stuff that you were doing this whole time. All right, so we're kicking it up here on number 4, throwing the variables in, but don't worry, process is still the same, right? Outside times outside. Now, this first one doesn't have an outside. If that bothers you, you can think of it like a 1, right? The invisible 1. So 1 times 2 would give me 2. But if there's nothing outside, then you just keep the outside of the other one. And then I have inside times inside. Now be careful with this, right? So I'll have 15 times 3 on the inside, which gives me 45. I'll have x squared times x to the first. X squared times x to the first gives me x to the third, right? There'd be 3 x's total then. And then y to the first times y to the third gives me y to the fourth. All right, so I did all my multiplying. Now I have to start my simplifying. Square root of 45 would break into square root of 9 and the square root of 5. Let's see, x to the third, that is not a perfect square because the exponent is odd. So I break that into the square root of x and the square root of x squared. Y to the fourth, though, that is a perfect square because that is an even exponent. All right, so let's see what we have. Make sure I bring the 2 down to the outside that was there already and multiply it by the square root of 9 is 3. Let's see, x squared of x squared is x, and the square root of y to the fourth is y squared. Those were all my perfect squares, and I have 5x left on the inside. All right, now I just need to multiply the 2 times 3 on the outside, so I get 6xy squared radical 5x for my final answer on this one. So again, just multiply first and then simplify like we've been doing this entire time. All right, let's take a look at number 5 here. I've got radical 8x times radical 32x to the 8th. See if you can pause your video and do this one on your own. All right, so the first way that you could do this is just to start multiplying. Both of these things are inside, so I'm going to multiply inside times inside. Oh boy, let's see though. 8 times 32. Let's see, well that'd be 240 plus 16 is 256 on the inside of my radical. And then I have x to the first times x to the 8th, which would give me x to the 9th. All right, 256. And I have to break down radical 256. So I have to break down radical 256. Now, luckily enough, I know my perfect squares here that are bigger than 15, and I know that 256 is actually a perfect square. The square root of 256 is 16, so I'm good there. Whew, thank goodness. But I know that x to the 9th is not a perfect square because that's an odd exponent. So remember the trick that I take just one and take it off. All the rest go in the other radical. Okay. So now let's see again. Square root of 256 becomes 16. The square root of x to the 8th is x to the 4th. And I just have radical x left on the inside. Now that is one way to do it, but I ended up with some pretty big numbers I had to break down. So another way to do this, if I go back to the beginning, times radical 32x to the 8th, original problem, I could reduce each one first and then multiply. Now, a lot of times that means that you're going to have to reduce more than once, but the numbers will be easier. So in this case, I would have 2 radical 2x from the first one times 4x to the 4th radical 2, right? Square root of 16 is 4. Square root of x to the 8th is x to the 4th. 2 is left in here. Okay, now I can go ahead and do my multiplying. Outside times outside, 2 times 4x to the 4th gives me 8x to the 4th. And inside times inside, radical 4x. Now that's not nearly so bad to reduce. Square root of 4, that's a perfect square. X is going to stay put. So I'll have, bring this guy down, 8x to the 4th times 2 radical x, and then just multiply my 8 times 2, which gives me 16x to the 4th radical x. Now it is more steps for sure, because you reduce and then you multiply and then you reduce again, but they were way easier numbers, right? I could fly through that when I really had to stop and think. And if you didn't know that perfect square of 256, that would take you some time, wouldn't it? So just keep that in mind. You don't have to multiply first and then simplify. You could simplify first and then multiply, but you're going to have to simplify again, most likely. All right, number 6 now, looking like a little bit different here. Now, remember, what would you do if you have a number outside of parentheses? We would distribute, right? And remember that distributing is multiplying. So I'm going to do the same thing. So my first distributing will be the square root of 6 times the square root of 8. Square root of 6 times the square root of 8. Both are inside, so I'd get square root of 48. Then I'm going to multiply. I'm going to distribute here, square root of 6 times negative 5. Now be careful. Negative 5 is on the outside. Square root of 6 is on the inside. So this will be minus 5 radical 6. You can think of that 1 on the outside, right? Negative 5 times 1 gives me negative 5 on the outside. Radical 6 is going to stay as radical 6. So that's usually the trickiest part when we're looking at outsides and insides when you're distributing like this. But notice I had 2 terms. Just thinking about when you distribute with regular numbers and variables, if there's 2 terms in the parentheses, when you distribute, you end up with 2 terms again, right? So same idea here, so be careful. Now I'm adding though, right? Well, technically subtracting. I have radical 48 minus 5 radical 6. So I'm kind of combining this lesson with the last lesson of adding and subtracting. So now I cannot combine these two because they are not like radicals. What I need to do is just double check and see if I can simplify this if they become like radicals. So radical 48 becomes square root of 16 and the square root of 3. 16 is a perfect square, so it's going to become radical, square root of 16 is 4. So 4, radical 3 is staying put. Bring down the minus 5 radical 6. Again, they are not like radicals. One's a radical 3, one's a radical 6, so I cannot combine them. So my final answer is just 4 radical 3 minus 5 radical 6. So this distributing idea really combines multiplying with adding and subtracting from the last lesson. All right, I got one more of those for you to do. Try this one on your own. Make sure that you understand the distributing. Okay, so the first thing I'm going to distribute, I have 4 radical 15 times 4. 4 and 4 are both on the outside, so that gives me 16 on the outside. And I have radical 15 on the inside and nothing to multiply it by on this first term. So 16 radical 15 for my first distributing. Then I'm going to distribute the 4 radical 15 times the 3 radical 6. 4 times 3 are both on the outside, so I get positive 12. 15 times 6 are both on the inside. 15 times 6 gives me 90. So I've got 12 radical 90 for my second distributing. There's my 2 terms, the 2 different things that I multiplied when I distributed. Now I just need to try and reduce. If I look at my first one, square root of 15, let's see, factors of 15 are 5 and 3. Neither one perfect squares, nothing I can do on that one. My next one, I'm looking at the square root of 90. That I know I can reduce. That becomes the square root of 9 times the square root of 10, right? 10 is 5 times 2, not perfect squares. All right, so square root of 9. Let's see, so I'm going to bring down my 12 here. Square root of 9 is 3, so I have 12 times 3 on the outside now. Square root of 10 staying put. Bringing down my 16 radical 15 so I don't forget it up there up top. Let's see now. Next thing I need to do is multiply my 12 times 3. So I have 16 radical 15 plus 36 radical 10. Those are not like terms, like radicals, excuse me. Radical 15 and radical 10 are not like radicals, so I can't do anything else. There is my final answer for distributing. All right, that wraps it up. If you can do that, you can do anything. So just remember, you can multiply any radicals. They do not have to be like radicals to multiply them. Just like any numbers at all, with variables, you can multiply anything that you want. When you're multiplying, inside times inside stays inside. Outside times outside stays outside. Don't forget to simplify. You can either do it before and or after, right? If you don't have to do it before, you can just multiply and then simplify after. If you do simplify before, it'll make your numbers easier, but then you'll probably have to also simplify again after multiplying. And just be careful to watch your insides and outsides when you're distributing, and make sure that you only combine, make sure you only add together anything that are like radicals once you get the two terms and you're adding or subtracting.